Hello, this is Oliver, and I'm the product manager for the Cinemeric Edge applications Analyze MyWorkpiece Capture and Analyze MyWorkpiece Monitor. In this tutorial, I will guide you through all the steps that are necessary in order to install and commission those two apps. And we will go through all the steps, which will be installing Analyze MyWorkpiece Capture, then installing the so-called Samba server on the Cinemeric Edge device, and finally we will also then install and commission Analyze MyWorkpiece Monitor. So let's get started. The first step is we open up the Edge management. So this is my Cinemeric Edge device that is currently onboarded. And as a precondition in order to install and also use Analyze MyWorkpiece Capture, you need first a commissioned and installed adapter framework and Cinemeric adapter. So let's get started. First of all, we decide to install a new application. And the application we will be installing is called MyWorkpiece Capture, so that stands for Analyze MyWorkpiece Capture. So we select it. And then we are looking for the most current release, which is currently the version 2.4, build 16. We accept the terms and conditions, and then we hit the save button. And now the download of the application is being started. And we can check the progress of it, clicking on jobs, and there we can see that the download is starting instantaneously. If we would like to, we can click the refresh button, and now we see an updated state telling us that the application is now being downloaded to the Edge device. And after a while, this process is being finished. This you can see when the state has been reached to activate it. If we now go back to the App Management tab and hit the refresh button, we now see the freshly installed MyWorkpiece Capture application. What we will do next is install an instance of the application, but before doing that, in the meantime, in the background, let's install an application called Samba server. The Samba server will be necessary to communicate between Analyze MyWorkpiece Capture and the Cinemeric Operate, which is the HMI of the CNC. And here we select the version 3.0 because we do this on an Edge firmware version 3.1. It's exactly the same process. First of all, we accept the terms and conditions, and then we hit the save button. Now, while the Samba server is being downloaded and installed in the background, we make the next steps in order to install and commission the instance of Analyze MyWorkpiece Capture. Therefore, we hit the install button and click the confirm button here. And right now, Capture is stopped. That means it's not running yet. And so before we do that, let's have a look at the app instance configuration. So every Cinemeric Edge app has a distinct instance configuration, and the one from Analyze MyWorkpiece Capture is very important. Here you define which HF signals are being recorded on your machine, and you define here basically how many axes your machine has. The default configuration of Analyze MyWorkpiece Capture assumes that you are using a 5-axis machine with the configuration of an X1, Y1, C1, and a Z1, B1, and a spindle axis. So that's quite a default 5-axis machine. And also the default configuration contains all available HF signals, starting from the cycle counter, of course, then the encoder position, the commanded positions, and so on. So I will not go through all of them now, but just keep in mind that on the default configuration, all the signals that Cinemeric Edge offers in conjunction with the Cinemeric CNC are being recorded. So in my particular example, I'm using here a 3-axis machine with 1 spindle. That means the fourth and the fifth axis are not going to be recorded. There are a couple of ways how to remove all those signals. Yeah, it's basically 3 ways. I choose going to the code section, and unfortunately this is now quite some manual task, but what would be necessary now in my particular case is removing the fourth and the fifth axis and getting this SP1 with me, so the spindle, because yeah, it's a 3-axis machine setup now, having X1, Y1 and Z1, and the spindle signal. And we basically have to repeat this for all the other signals now. Before doing that, let me show you also another very important point. So here basically you define what you will then later see on the Capture web UI as available signals to be recorded. And the second part of the configuration is that you also here define to which signals this application is subscribing to on the data bus of the Cinemeric Edge. So what you're doing basically here is repeating the steps that you just did before. You remove all the addresses that you're not gonna listen to. So in this particular case, we only want to record EngPOS1 to EngPOS4. That means I remove the 5th and the 6th signal, and we repeat this for the DES-POS and the control POS and so on. So in the background I prepared a template which I will now simply copy and paste. So what I'm now doing is removing completely the whole configuration we can see here, and I paste my own saved configuration which I've stored in a particular or in an extra text file, and I paste this all here, and as you can see this is now configured in that way that all the signals only go from the index 1 to 4, EngPOS 1 to 4, DES-POS 1 to 4 and so on. And so that I do not have to do that manually all the time, you know, you can with Control A as an example on your keyboard and then do a right click and copy. You can now copy this content to a text editor and save it to use it for further purpose. And also now here on top, all those signals like power as an example only goes from 1 to 4. Now once this is done, we have now configured Capture to record all the necessary, to be able to record all the necessary signals from index 1 to 4. We hit the save button, and now this configuration is being sent down to the Cinemeric Edge device and configures Capture in the background. In the meantime, let's hit the refresh button and we should now be able to see the Samba server. As you might remember, we started to download it in the background and now it's downloaded. We also followed the same process. We hit the install button first. Now an app instance is being installed. And again here, before we start this app instance, we need to configure it first. The configuration here is quite easier compared to the one in Capture, but nevertheless there are 2 very important fields you have to define here. As I said, the Samba server is a mean of communication between the Cinemeric Edge device and the Cinemeric Operate HMI. We will embed a network drive into the Cinemeric Operate, and this network drive needs some login credentials based on a username and a password, and this one you are basically defining here. You have to take care a little bit. You cannot define passwords like that. Like this is a very simple one, and the Cinemeric Edge platform will not allow those kind of simple passwords. You have to use a little bit more complex one, and you also have to remember this password, or at least, you know, copy it later on, because you have to type it in later into the Cinemeric Operate HMI also, which I will show you then later on. So for my particular example, I decided to use this password, and here as a username we use monitor. We hit the save button again. This app instance configuration is also now being sent down to the Cinemeric Edge device and is configuring the Samba server. We can now start the app instances. Actually, it doesn't matter which one you start first. Let's start with the Samba server first, and then we continue with Capture. And if you would like to see when are the apps, let's say, available, or when they can be used on the Cinemeric Edge device, the first step is to hit the Jobs tab here and then go to the Configure tab. And let's click Refresh to see what's the current state, and we can now see there are still 3 configuration jobs going on. And when they are all on state OK, that means the 2 apps we just configured and started up, they are now in the state where they can be used. In the meantime, I also would like to inform you once more that if it hasn't already happened in other tutorials, you can always access the application's documentation either here on MindSphere side. So you click this book icon, and there you see first of all the terms and conditions, and then on the section additional documents you can see the operating manual and other material that comes with the software. It highly depends on the application. Here with Analyze MyWorkpiece Capture we offer an output format description also, and a restrictions document and so on. So before we start using Analyze MyWorkpiece Capture on the Cinemeric Edge device, we must finalize the configuration of the Samba server. So what comes next is we go to the Cinemeric Operate and embed as a new network drive the Cinemeric Edge device. So here I'm now connected with my Cinemeric CNC, and in detail the steps might be different a little bit on your machine. I will try to show it as generic as possible. So first of all, we hit the menu select button, or if you are connected with a VNC software, you hit the F10 button, and then we go to Setup and make sure that your current access level is manufacturer. And then we go to the HMI soft key, and from here we go to the logical drives. Once this is clicked, we now can embed a new network drive. First of all, we select here a free one. I choose the second one. If the second one is already in use, then you should scroll down until you find one which has the type no drive. We click here on the combo box and select network Windows. And in the path, this is now very critical, we have to type in the following information. We start with 2 slashes, and then we must type in the local IP address of your Cinemeric Edge device, another slash, and then in small letters share. Normally this IP is always the same, so it's 192, 168 to 14 to 49. Sometimes it may differ, and this then you need to check in your Cinemeric Edge configuration, but I would say in 99% of the cases it's this IP address. And now you only need to define 2 more things. First of all, the username. And the question is what to type in here as a username and a password. Therefore, we go back to the Samba server configuration and have a look at the app instance configuration, and there we see the username and password, and this is exactly the one you need on the Cinemeric Operate. So I start typing in the username monitor here and paste it here. Okay. And paste it here. And now we can hit the OK button. But one minor thing, we can define here a soft key text allowing us to identify the network drive later on the operator panel. I choose here simply Edge. Let's hit the OK button. And we did not get any error message. That means that the network drive was successfully embedded. To make sure we can see it, we click the menu select button again. We go then to the program manager, and there we see a new network drive called Edge. We can click it, and there we can see that we have at least a connection. So in this particular case, using Analyze MyWorkpiece Capture or Capture for Analysis, the Samba drive is only being used to access logging information, which can also be accessed using the Cinemeric Edge diagnosis page. In further versions of Analyze MyWorkpiece Capture or Capture for Analysis, the recording files have also been stored on the Samba drive. Since the version 2.4, this is not done anymore. So currently the Samba drive is there only being used for the logging information. But if you use it with other Cinemeric Edge applications such as Analyze My Machine Condition, the Samba drive plays a very critical role, but details in another tutorial regarding Analyze My Machine Condition. So we have now successfully commissioned the Analyze MyWorkpiece Capture application and the Samba server. And now let's have a look together how to further commission Analyze MyWorkpiece Capture. Before we can use it, there is just one more step that needs to be done, and that is setting up a valid username. So in order to do so, we establish the first time a connection to our Cinemeric Edge device. Therefore, you either need to call the DNS name or the IP address. In my particular case, I am choosing the IP address, which is visible here. And then you need to also to type in this port. And when the first time you are establishing the connection, it might be that you also need to type in https:// and then the IP address. We hit the enter button, and now we see the mini web. And the mini web is the administration environment of the Cinemeric Edge device. And you now need to log in as an administrator. Then we hit the login button and we go to the security section, and there we go to the user manager. In the user manager, we first have to create a new group called AMW Capture. On my device, you can see it's already created, but it would look as follows. You hit the add group button, you type in AMW Capture, and then you hit the add group button. Then we would see a new group, which is called AMW Capture. And then we need to create a new user and assign it to the AMW Capture group. That could be any name, so feel free to choose one. In my case, I decide to call it MyWorkpiece, and then I have to define a safe password, and then I need to hit the Add New User button. We have now created the MyWorkpiece user, and now we need to assign it to the AMW Capture group. And I do this here by clicking the check mark and then Save User. And that's pretty much it. You can now log out from the mini web. And now we can start the first time the Analyze MyWorkpiece Capture web UI. This can be done by accessing the diag page. The Cinematic Edge shows me this welcome screen here. And we can now log in as an administrator again. Then we go to the app management section, and then I go here to the Edge apps, where I now see all the installed Edge apps which have a UI. So you can see here Analyze MyWorkpiece Capture, and I use this to go to the UI of Capture. So a new tab is now being opened, which also has the IP address of my Cinematic Edge device, and after the slash comes the AMW capture. So you have now the possibility to either call the capture UI with this button, or in the future what you can also do is just copy that, remove this, and if we now just add the IP address /AMW capture, hit the enter button, the capture UI also shows up. Okay, so this is the main section for Analyze MyWorkpiece Capture. We have different areas, a so-called job manager, a job editor. You can see audit events, that's basically a logging page, and there is a data management section. And you have also here an area where you can see notifications on different levels, like info, warning, or error. And then there is the settings area. In the settings, you have the possibility to define a couple of things, such as what shall Analyze MyWorkpiece Capture do in the event if the Cinematic Edge device is running low on data volume on the disk. You can set a threshold here, like if 80% is occupied, then you have the choice to stop the recording and do not delete any data. By doing so, you do not lose any old data, but new data is not being created. Or you have the second strategy stating automatically delete the oldest entries and continue recording. So that's basically a ring buffer, and that means that older data is being lost in the situation where you do a constant recording, as an example. You can also specify the split size. So Analyze MyWorkpiece Capture creates JSON files and puts the process data into the JSON files, and here you can define when those JSON files should be split. The standard setting is 100 megabyte, but you can also decrease it to 10 megabyte. The last setting is regarding time zones. It is recommended to leave it as it is, I would say. So the standard settings are always based on UTC time. But if you would like to use a local time zone, then you also have the possibility using this slider to specify or use your local time zone, which is necessary when you use time-based start and stop triggers, about which we will talk in a minute. So we now hit the save button to save our changes. And now we go back to the job manager. On the job manager page, you see all the available recording jobs. Currently the list is empty. So let's create a new one by hitting the create new job button. And you basically have to define two things. One is the HF signals to be recorded and also the low frequency signals to be recorded. And then the trigger section. If we collapse this list of HF signals, you see all the available signals we defined on MindSphere side. So as an example, if we collapse the actual access position group, we see angpos 1 to 4. And as you probably remember, we removed the entries for EncPOS 5 and 6, and that's also the reason why we now only see the signals from 1 to 4. If you would like to record all the available signals, you simply have to click the check mark here on top, and then implicitly all the available signals are being recorded. And if for some reason you do not want to record a specific signal because it's probably not available on your machine, because it doesn't have a second encoder as an example, or you are not interested in your use case, then you can hit the check mark here. So from this group, no signals now being recorded, and you can see here now by the color of the checkbox that not all signals are being recorded. So for now, I would like to record all these signals. That's why I bring back the check mark here again, and let's uncollapse this group. The low frequency signals are there to record so-called BTSS variables coming from the cinemeric CNC. In this tutorial, I will not go further into any detail into this, since for the commissioning with Analyze MyWorkpiece Monitor and the use case with Analyze MyWorkpiece Monitor, this currently does not play a role, but just in a few words, you can use this section by adding a signal group and then some signals to record so-called BTSS signals. Let's just remove this for now. And let's go to the trigger section. The trigger section is very important because here you define basically when shall data be recorded from your cinemeric CNC. The most easy one is the manual trigger type. So manual means you decide here on the UI whether a job shall be started or stopped. You can also use time-based triggers. You can say, okay, please start the recording at a specific time. As an example, let's start it on Monday, 8 AM. Or we can also use periodic trigger and say, okay, every day start at 8 AM. Oops. And stop it after, as an example, 14 times. The next type of trigger is a so-called data-based trigger. There you can say, okay, if, as an example, the load of the spindle is higher than, let's say, 80%, then please start a recording. And the last type is the so-called event-based triggers that is being used in conjunction with NC-based events. So what is an event? When NC code is executed, we call this a so-called HF block event, so a high-frequency block event. And in this HF block event, the NC code is contained. And this NC code then can be used to start or stop the recording of Analyze MyWorkpiece Capture. And this NC code is basically coming from the NC program that you are executing on your CNC. Therefore, I've prepared an example of a CNC program we will be using in this tutorial. And let's have a look at it. So it's stored in the part programs and it's called in German Kreisfahrt. That means it's basically a circle we are doing here. So let's just open it. And as we can see here, this is basically the main line traveling a circle with a speed of 5 meters per minute. And there are now two very important lines that I added here. One is called the G4F0 :start and then G4F0 stop. And these comments, start and stop, we will be using to start and stop the recording of capture. Just one hint, why do I write G4F0? Why did I not simply write something like that, colon and start? And this would not work as a start trigger because the Cinemeric Edge device only receives NC code that has not been removed by the preprocessor of the Cinemeric CNC. And the Cinemeric CNC, as an example, removes all the comments from your NC part program. And therefore you somehow have to combine your comment with a G code that is not being removed by the preprocessor. And one valid way by doing so is adding a G4F0 section and then write the comment later on. And what does G4F0 basically mean? It just means that the NC here is waiting for 0 seconds. So you are basically waiting 1 IPO cycle. And that means we can now remove this line here again. And you can also use it for more complex triggers, such as, I don't know, let's say capture start ID 4711, and we could now use this whole line also to start a recording. Yeah, and this comes handy when you're having several sections that you would like to start or stop recording. For now, let's just stick here with start, and let's close the NC program again. And if we now go back to the Capture UI, we take those triggers. I now say, okay, please start the recording on a certain event. The event should take place on the first channel. Since I only have a 1-channel machine, it only makes sense for me to select the first channel. And now I need to tell Capture when to start the recording, and I type in now here start. And this is because I gave one of the lines the comment G4F0 start. I could basically also copy, the whole line if I would like to. By doing so, the recording would now also start here, but it's not really necessary in that case because we also compare just subsections of the line, and if it fits, the recording also starts. And because the condition is true, so we keep it here with start, and that's basically enough for this simple use case. If there are sometimes situations where one simple NC command is not enough to find the right trigger, then you need to find a more complex way to find the right starting section. So you can, as an example, use the so-called call stack level. The call stack level defines the level of a subprogram. So from an NC program you can call subprograms, and these subprograms can call other subprograms again, and each level you are in when calling a subprogram, this is called the call stack level. So in an example, if I have in the second subprogram being called also a start comment, then I hit this to 2, and then my NC code would be my recording would be starting there. This can become even more complex, so I can also use the line number of the NC code and the tool ID, the program path. But this is all not necessary in this simple example. So let's just stick with the NC code start. And we also would like to stop the recording at some time. So therefore I select also channel 1 and stop, because at the end there was the section. If we have a look again, the section with G4F0 stop. So I define a name here. Here I define it as circle tutorial capture. And that's basically it. Now we hit the save button. Capture now creates the recording job. And in the job manager section, to which Capture brings us automatically once the saving operation has been executed, we can see the circle tutorial capture job. And if we would like to, we can now edit the job configuration again. We could remove it, we could export it. But for now, I would say let's activate it. What is basically happening now, the data is not being recorded yet. Capture now waits for the start trigger, and only when the starting condition is true, then the recording starts. And the same goes for the stop condition, so the recording then stops once the stop condition was true. What I'm doing next is executing the NC program on my Cinemeric CNC device. And what you will now see is that the recording at some point automatically starts and also stops. So as you can probably hear, I activated the drives from the CNC, and I in the meantime selected the NC program, so the circle one, and you can see here now again the circle command and also the start stop. And I would now activate this NC program, so hit the NC start button, and let's just see what happens on the Capture UI. As you could see, in the meantime, there was such a red button indicating that Capture was recording data. And we can now, if we go to the Data Management tab, we see that in the Circle Tutorial Capture there is a new job run. And this job run contains one file. And this was just executed. So since it was quite a short execution time, it just contains 500 kilobytes. And yeah, this basically tells us that the recording was successful. The next step of this tutorial will be installing and commissioning Analyze MyWorkpiece Monitor. Analyze MyWorkpiece Monitor will be then used as a process monitor, and we will together create and train a monitoring model and execute a monitoring. And by doing so, we need reference data, and that means that I will now, in the background, before we install and commission Analyze MyWorkpiece Monitor, will create a little bit more reference data. So we will always use the circle program, and I will now increase the number of runs by running the NC program multiple times. So as you can see here, I executed the circle program 14 more times. So we have now 15 job runs being recorded while it was executed, which generated 8 megabytes of data. And with this, we will now close the section of commissioning and also using Analyze MyWorkpiece Capture. we now recorded process data from the Cinemeric CNC, and we created a set of equal process data from the circle program, and this one will later be used as reference data set using Analyze MyWorkpiece Monitor. We will now be installing and commissioning Analyze MyWorkpiece Monitor, and I will also guide you through all the steps that are necessary in order to be able to monitor your process using Analyze MyWorkpiece Monitor. Step number 1, in order to install this Cinemeric Edge application, you go to the app management. In order to get started, we must select a new application, and we must look for AMW Monitor, which stands for Analyze MyWorkpiece Monitor. Then you select the version you would like to install. Currently, the most current version is 202-96, which runs on Cinemeric Edge 3.0 and 3.1. This one gets selected. We accept the terms and conditions, and we hit the save button. Now a process is being started where in the background the application gets downloaded. So after a while we click the refresh button, and we now see the freshly downloaded AMW monitor. We click on install, which installs now a new application instance on the Cinemeric Edge device. And before hitting the start button, we need to configure it first. If you need details on how to properly commission AMW monitor, you can always click this book icon, and there you see the installation manual and Analyze MyWorkpiece Monitor, and also then later on the operating manual if you need help during operating the software. Okay, and now let's together configure the application. Therefore we hit the Edit App Instance configuration, and I go directly to the code view. And the configuration of Analyze MyWorkpiece Monitor is in some details quite, I would say, special. There are a few things you need to take care of, and we will go through them now step by step. First of all, there is this address field indicating an MGUD variable, which will later be used to feedback the process information of Analyze MyWorkpiece Monitor to your CNC. So when a process failed or a process was successful, this information is not only stored on the monitor web UI, but also will be fed back to the Cinemeric CNC, and this is done using an MGUD variable, and every variable has a name or needs to have a name, and you can define it here. By default it's called edge underline AMW monitor underline result, and I would say we go with a default. If for some reason this name is already used, then you can change it here. Then we need to define the signals that need to be subscribed to for this application. This is a little bit similar to AMW Capture, where you also have to specify these addresses. By default, it's the encoder position, the commanded position, and the torque values for these axes. Since we are having here a 3-axis machine in the setup, we will only go for the encoder and the DESPOS values. That's why I copy and paste from my configuration now the signals. So I pasted here now cycle, then the DESPOS 1, 2, 3, the encoder position 1, 2, 3, and the torque. The torque I will later be using as a monitoring signal. So in this case we will take torque 1, so from the x1 axis, as a signal that gets monitored in order to identify process anomalies. And the signals here, the despos, we need to calculate the path. And I could also now in my example remove the encpos, but I leave it in for now. And in this section you specify once more the signals that are being used for the monitoring. Since I use as a path axis the desired positions, I need to specify them here. You could here again use the encoder positions also, but since the desired positions have less noise and gives us a little bit more accuracy when calculating the path, I select the desired positions here for the 3 axes. And now here come 2 signals that are very important because I will use them later on, or one of them, I think it's torque 1, for the process monitoring. So this will be my process monitoring variable, which tells me whether my process is inside or outside the boundaries. And here I select the address from the HF data bus. Here I define a so-called alias that helps me later on to identify this variable on the web user interface of monitor. And I personally find x1 torque a little bit more helpful than torque 1. And then please indicate this field is public with true. If you do not specify it at all, like that, or if you do it like that, is public false, you will not be able to select this variable for monitoring. So please set this to true, and then on the web UI you are then good to go and select this one as a monitoring signal. The last step is to define the channels of your machine. Since I only have one channel here on my test setup, I only selected it and I gave it a name that helps me to identify it. And if, as an example, you have a machine with 2 channels, you would need to specify it like that, 2, and then whatever the channel does, so let's assume it does turning, you should write down that turning. But this name only helps you on the web UI, so you can write down there anything that helps you later on the web UI to identify this channel. So since I only have one channel, I leave it like that. And then we have finally here again the path axes that are being used to calculate the traveled path of the tool. So since monitor does not work in the time domain, but in the path domain when it comes to the monitoring, monitor somehow needs to calculate the path. And currently we do it in that way that you specify 3 axes, and you can select here again between the encpos or the despos, and it's recommended to select the despos, although there might be a small difference. But since the desired position values have less noise compared to the encoder, you can slightly increase the quality of your monitoring models using the despos. And last but not least, 2 values here. The model step size. By standard it's 0.05. You can decrease it, and it basically defines the size or the distance between the interpolation points of your path dependent monitoring model. And if your model is very, very big due to a long running process or a very, let's say, fast running process, and if you want to decrease the size of your model, you can increase the value here, which increases the distance between the interpolation points, which ultimately decreases the model size. I would start with the default value here, but if you recognize issues due to 2 big models then feel free to increase it, but then also you need to cope with smaller quality of the monitoring model. So for now I go with the default value of 0.05, and then we have the last field that needs to be specified here. We have AMW Capture so Analyze MyWorkpiece Capture as a recording application for the reference data. And if you have Analyze MyWorkpiece Capture for analysis, you need to write down here Capture for analysis. This is the current behavior in the version 2 of Analyze MyWorkpiece Monitor. In the future, this field can also be left out. So if you recognize app instance configuration without capture type, then you have a version where Monitor automatically detects which capture is being used. So for now, let's leave it like that. One last information. If you ever run into the situation where you need to clean out the whole database of Analyze MyWorkpiece Monitor or parts of it, there is a functionality where you can add here a new field called PG clean app type. And if I write down here all and I would hit the save button, and I do not do it now, you have the possibility to completely clean up the database. That can be necessary under certain circumstances. If, as an example, you only would like to remove the TDUs and keep the rest, then you write down here TDU. Please check the README file. It contains all the allowed commands in order to reset the database. So for now we leave it like that. And let's check the configuration once more, and let's hit the save button. And this configuration is now being downloaded to this numeric edge device, and we can now also start the app instance. So while this is being performed in the meantime, we now can set up two more things. One is a user on the mini web that has access to the AMW Monitor application, and then also we set up the MGUD variable on the numeric CNC. So we now type in the IP address of our numeric edge device, including the port 5443, and then we come to the mini web administration page. We type in the credentials that have been set up and log in. We go to the security section and then the user manager tab, and then we need to create a new group called AMW Monitor. Add this group, and now we need to add a new user. Give it a strong password. And then we need to assign this user to the AMW Monitor group. And we click Save User. And now the MyWorkpiece user is now able to access the Analyze MyWorkpiece Monitor web UI. The next step we need to do is we need to create the MGUD variable on the numeric. So basically what we need to do now is we create a new MGUD variable. So on the operate, you hit the menu select button, you go to the setup and then the system data soft key. From there you go to the NC data and go to the folder definitions, and then you go into the MGUD file, and there you have to type in the following code, which you can see here. So dev nck int, and then here comes now a very important part, the edge AMW monitor result, and you probably might remember this one. This is the variable we have specified on the MindSphere configuration. So as a reminder again, let's go to MindSphere. Let's collapse the AMW monitor application and look to the app instance configuration. And there we see this address field, and here we have Edge AMW monitor result. And this you need exactly here also in your definitions file. And then you click the close button, and then you hit the activate button. So when you see this message, the MQT variable has successfully been created. We can also check it. We hit the menu select button and click on parameter. And if we click on user variable and global GUD, you see here this Edge AMW monitor result, which is currently initiated with 999. And we will see later on why this value is important. For now, we are able to go to the AMW monitor web UI. And to make this quickly, I go to the diagnose page of my Cinematic Edge device. That is listing all the installed apps, and now I see here AMW monitor. And if I click Open UI, it brings me directly to the Analyze MyWorkpiece monitor application. I could have also used this path here, so the IP address of my Edge device, including the port and then the AMW monitor, that would have also been resulted in the same. Now there are several sections on Analyze MyWorkpiece monitor we need to follow. Before doing that, let's go to the global settings of the application. Here you can specify a machine name. I call this now tutorial machine. This name will be indicated later on the job reports. And you can also specify here an address of the workpiece ID. The workpiece ID will also be indicated on the job reports. Since I do not have a workpiece ID address here specifically, I take the program name. You have to define always BTSS addresses. So if on your machine you have a workpiece ID stored somewhere which is accessible using BTSS, you can specify the address here. And you can also specify number of days until the logs are being removed. Then you hit the save button and we go back to the overview. And before we start, just some additional information. Here on the top right, you have always the possibility to switch languages between currently English and German. You can change the password, which will basically lead you to the MiniWeb administration page. And if you click here on the hamburger menu, you have always access to the user manual of Analyze MyWorkpiece monitor. Okay, now let's get started. When using Analyze MyWorkpiece monitor, in order to establish a monitoring process, you basically have to always follow the following steps, starting from import capture data to create so-called training data unit sets. After that, you have to train models, or what we do here is today train one model. Then you have to manage your monitoring jobs. And once a monitoring job has been executed, you need to analyze the monitoring results. So let's get started with step number one. As you might remember, we recorded process data from the Circle program, the NC program with Analyze MyWorkpiece Capture. And now we need to import this data into the monitor database. First step is we click on the import button, and then monitor is calling internally the interface of Analyze MyWorkpiece Capture and is loading all the available jobs. After a while, you should be able to see all the capture jobs. And as you might remember, we only have created one capture job. If we would have had multiple capture jobs, we would now also see those multiple jobs here. We see the circle tutorial capture job. We see that it has 15 available runs, and currently we only have, or we haven't imported any run yet. This we will do now by clicking on the respective run, and after a couple of seconds, Monitor will list all the available capture runs. You get some meta information, how long these jobs were and when they were executed, and also a state whether it was imported or not. You can import them one by one if you would like to, or a little bit more handy is you click the check mark here. Now all are selected and all the selected ones are getting imported. And if we see this window here now, the import is being started. You do not have to stay here all the time. Based on the data amount you would like to import, it can take a couple of minutes. If you would like to, you can close the tab and come back later. Monitor is importing the data in the background. Okay, we are now in the state of having nearly imported all the 15 capture runs. And as you can see, now here comes the final message, which we can confirm, and we all see the state imported on all the capture runs. So the first step here is now finished, and now we come to the step where we create a training data unit set. A training data unit set is basically used to train a monitoring model. If you need detailed information on that, I recommend the user manual, which you can access here. Basically what it is similar process data in the path domain, allowing Analyze MyWorkpiece Monitor to create monitoring models. To create training data unit sets, you need to create a job, and here you should define a name that helps you later on to identify the TDU set. And here I use the circle TDU tutorial. And now we need to define which capture job reference shall be used. Since we only have one, we select this one. If you have multiple ones, then you need to select the correct one. And now we need to specify from which channel the process information should be taken, since capture records the data from all the channels. And we take the only one which is existing, and as you might remember, the milling one was also defined in the MindSphere, in the configuration, in the app instance configuration. Now we need to tell Analyze MyWorkpiece Monitor where does a TDU start and where does it stop. Because of the example we have selected here, the TDU also starts at the same point where the capture job starts and stops. So I select here in C code start and stop. But this does not always have to be the case. So imagine the situation that you have two operations recorded in one capture run. Then you might have different trigger values for the start and the stop situation in order to slice the two operations. One specific thing that needs to be done when using Analyze MyWorkpiece Monitor is you need to define so-called escape characters with a dot and a star to make sure that the triggers really work. So you cannot only write start and stop, you should write always before and after your desired trigger value a dot and a star. And if we remember the part program, it was this whole line with G4 F0. If we would like to use this as a start value, I would need to write the following. So dot star G4 F0. Then we had a colon, a semicolon. Before writing this, we need to write a backslash. So backslash semicolon. And then we would have the start. But this is not necessary. By defining it like that, the start trigger would also work for this TDU. And on this tab here, run selection, we now tell monitor out of which capture run it shall take the TDU data. I would like to do this for all the imported runs. And now monitor brings us back to this TDU job management page. And what we now see is that it's currently in the state of processing this, and it counts the number of created TDUs. So what it basically does now is processing all the data and looking for the start and the stop trigger. And once this was found, the process data is being sliced and transformed from the time domain to the path domain using the path access that you also have specified in the MindSphere configuration. So after a couple of minutes, the TDU generation job has been finished, and now we see 15 generated TDUs. If we hover over the I button, we can see once more what were the start and the stop trigger conditions for this TDU, and if we would like to, we could delete them now. Now we go back to the overview page, and here comes now the point where we train the model. So we have now imported reference data, we have sliced the reference data to distinct operations, and now we start the model training. Here you would have now the possibility to import a pre-trained model, which was trained externally. This can also be used with Analyze MyWorkpiece Monitor. For now, we create a new model using the data we have at hand. So let's call it Circle Model Tutorial. And now we need to define the TDU set reference. And here I select Circle TDU Tutorial. We need to define a training method. Currently only Six Sigma is supported. In the future, of course, Monitor will support further methodologies. And now here comes a very important part. We need to define which variable shall be used to monitor our process. Currently, we recommend to select the spindle torque, as the spindle torque indicates deviations from the process, and it also has a reference to the quality of your workpieces on the surface side. Since on my test setup I do not have a real spindle with me, I can only work with the torque of my X and Y axis, and that's why I select the torque 1 signal as a monitoring variable. Then Monitor wants to know a value called filter length. This one is used in order to smooth, so to use a low pass filtering on the imported process data and also on the monitoring variable. And by default this value is on 25. here you have to experiment a little bit. And I now set it to 75 in this particular example. Most of the time 25 is quite a good value to start. And again, here we have the trigger section where is defined where this model begins and ends. It's all grayed out because this information is directly taken from the TDU. And now here we define which TDUs shall be taken into account for this model. So this is basically a labeling step. And here you have to define or detect outliers. Here you should only use TDUs that indicate a good case. So this is the so-called reference data basically, which is used to train a model. And we have several attributes to identify potential outliers. The first one is the duration. If you have an example, if there is a process which has a much higher duration time or much lower compared to the others, you should definitely not use this as a TDU for the model training. Then we have the path length. This is a very important value, and we can already see here there is a deviation of 6 millimeters, and I would consider this as an outlier which shall not be taken into account for the model training. And finally, we also have the signal integral being offered. The signal integral is now taking or is calculating the integral of the selected monitoring variable. So monitor now takes the torque signal, draws it against the path length and calculates the integral of it. And by doing this, you can also observe deviations and potential outliers. So in this particular example, I select all the TDUs, but I will unselect the first one because I decide that a deviation of 6 millimeters for the path length is a potential outlier and it shall not be used to train my model. So I have now 14 TDUs selected and they will be used to calculate the model. The question is, how many TDUs shall be taken? There is no fixed rule. A rule of thumb says 5 is the absolute minimum and 20 is, let's say, an upper limit. With 20 and above, if you have good TDUs, the quality of the model is normally not increasing. So we have here 14, which is, I would say, in the middle. That's quite good. So in the end, we scroll down and hit the save button. And now we can start training the model. So monitor says, okay, you have labeled 14 TDUs as good and they will now be used to train the model. So let's start the training. And if we now go back to the model overview page, we now see that monitor started the processing, which is basically the calculation of the model. So the model has now been trained, and if desired, you can also export the model, and you would then download a JSON file, and there you can use the model in external systems as an example, or you can also store them for versioning in an external system, or if possible and if it makes sense, you can export it and import it to a different Cinemeric Edge device, also using Analyze MyWorkpiece Monitor. You can also remove it, but for now we go back to the overview page, and now we set up a monitoring job using the trained model. So at the beginning, the monitoring job list is empty. So let's create a new one and let's call it Circle Monitoring tutorial. The first value we have to define here is the job number, and this is now very important. If you think again about the MGUD variable, which is still currently instantiated with the value 999, the job number is being stored in the MGUD variable. So with a job number you are able to identify later on your monitoring jobs and which one has been executed. Since you can create multiple ones, you need a number or an information on the machine in order to react properly if there was an anomaly, which job has just been executed. So this number can be defined freely. So let's just take 4711 as an example. And if we look at the operate and we see this value is positive, so we will later now see when we execute the monitoring, and if it shows in the MGUD variable plus 4711, then we know on the machine that the last monitoring job was positive. It was a good result, so there was no anomaly. But if it's negative, like minus 4711, then we understand on the machine that this monitoring job, the circle monitoring tutorial job, was indicating an outlier. After having defined the job number, we define the model reference, so the used model, and since we only have trained one, we take the circle model tutorial. And now we need to select the channel, which is of course milling and the first channel, because I only have one channel here. And now we need to select the tracking signal. This is the one that is being used to detect process anomalies. Normally, I would say you do not choose the X1 torque. Of course, there can be use cases where it makes sense. For standard milling processes, we recommend to take the spindle torque, but since I do not have a spindle here in my setup, I select the torque from the X1 axis. And now we need to tell monitor one last time when to start the monitoring and to stop it. And yeah, the question is, why do we have to define here again the triggers? Why does monitor not take the triggers from the TDU or the monitoring model? And the answer is, sometimes there can be situations where you would like to monitor a subsection of your whole model. And since this can be the case, we developed it in that way that you can once more specify the triggers here. If you want, you can also now add a reporting variable here, a BTSS address variable, and you can create multiple ones. And this can be used as header data to identify your process later on. We leave this empty now, and yeah, if desired, you can also now add a comment here. This is only internally used on the web UI of Monitor and could also help you to understand later on why you created this monitoring job. So for now, let's save it, and this was the last step before we start the machine again and start the monitoring now. And what happens here is basically the same now as on Analyze MyWorkpiece Capture. We activate the monitoring job, and Analyze MyWorkpiece Monitor is now listening to the high frequency data bus on the cinematic edge and checks whether the start and stop condition is true, and based on that the monitoring is being started or stopped. I would now in the background start the circle program again, and let's just look what is happening on the UI. We now saw a similar thing as on the Capture UI. Whenever the start trigger was true, monitor got into a monitoring state. We could see it where this job control became gray. And once the stop condition was true, then the first time the monitoring was stopped, and then this I button here appeared. And this I button now leads us to the job reports page. I have now two possibilities to go there. Either I click on the I button to go directly, or if I click the Analyze Monitoring results here on the overview page, I also come to the analysis part. And now we see the following situation. We see here two processes that failed and two processes that were successful. So let's check the first one. We click here on the I button. And yeah, basically we see here now our monitoring signal, so the torque of the X1 axis. And we can see whether it's inside or outside the tolerance band. So let's zoom a little bit more into this section. And we can see here the green tolerance band, which is based on the Six Sigma model training and based on the 14 TDU set we have created. And we see that in this area, in this process run, the torque signal was always inside these boundaries. And if we click as an example here on the Axed one, we see here a couple of anomalies. So whenever this red line is here on top, it indicates that the monitoring signal is out of the boundaries. So let's just zoom into this area. And if we look very closely here, like very, very closely, we see that the torque signal did leave the green tolerance band. And that is why we have here an increased anomaly counter. We could also do this here in this section as an example. So let's zoom in, and we also see that the torque value is now above the maximum threshold of torque max. And that's why the anomaly counter has been increased. If we now check the operate screen again and go to this parameters page, we see that the Edge AMW monitor result is now minus 4711. So why is it minus? If we check again the very last executed monitoring job, we see here the end time and see the result as an X. So that was an anomaly. And if we also look at the graph, we can see that the monitoring signal a couple of times exceeded the limits, as we can see here. And this information is now fed back to the operate and to the CNC using this mgud variable. And by that you can now react to the situation. So as an example, before you start the execution of the next operation in your NC program, you can check the value, is it positive or negative, and if it's negative, then you can execute further actions. With that, we go back to the overview page, and we could now start the whole workflow again, from creating reference data for a new workpiece to importing it, until creating training data unit sets, train a new model, manage monitoring jobs, and in the end, analyze this data. And by having done that, I finalize now the tutorial for Analyze MyWorkpiece Monitor. And I hope you enjoyed the session and you learned the usage of the software application. And I wish you an increased productivity using Analyze MyWorkpiece Monitor. Thank you and see you next time.